This is the second part of lesson 1.5, still on page 29. The application this time is using Pythagorean theorem. So they are asking us to find the length of segment AB. And we're going to use the fact that this is going to make a right triangle for us. And I'm actually going to draw it over here because that grid has so much clutter on it right now that it's hard to actually, if I try and add things to it, it's not going to look very good. So here's my point A, or my vertex A, vertex B, this is C. So I have side C here, side A here, and side B here. Just a quick reminder that when we label triangles, they are labeled, the vertices are always labeled with capital letters, sides are labeled with lowercase letters, and in a triangle, we label them with the same letter as is opposite. So the side that's opposite vertex A is side A. The side opposite vertex C is side C. That only works in triangles, but it is a convention that we do follow. And now I'm just going to come back over here and I can see that the length of side A is 3 and the length of side B is 9. I counted that up before, haha. All right, now I can plug this into the equation. So I get c squared equals, my a squared becomes 3 squared, my b squared becomes 9 squared. I'm hoping you all do remember this. Pythagoras is just one of those things you are expected to know, and we can throw it at you anytime. So it becomes 9 plus 81, so c squared equals 90. So c is going to be the square root of 90. And then I need to put that into simplest mixed radical form because we always do that. That's just part of the simplifying things. So 90 is 9 times 10, so that's going to be 3 root 10. We sort of, when you started learning Pythagoras, we just kind of glossed over the fact that if c squared equals 90, there's actually 2 roots to it. There's a positive solution and a negative solution, but because the only time you've used this before is in Pythagoras and it's a length, a length is always positive. So that just kind of got glossed over. Anyway, there's our answer. And now we're going to look at the distance formula, which you probably saw in grade 10 at some point. It's actually just the Pythagoras. It's just into a formula to make it so you don't actually have to do the counting. What makes this easier to use is if you're given those values, the coordinates in a question, you can just write in what your x1 and your x2 and so on above those numbers. I would do it on the grid, but again, it's kind of hard. I think it would be kind of hard to see. So what I'm going to do is I'm going to come over here and I'm going to say point A is -6, -2, and point B is at 3, 1. And then I'm going to label this. This column is x's and this column is y, and I'm going to call this point 1 and this is point 2. So when I come to plug things into my formula, I get d equals the square root. So I have to find, bracket, x2. So I come over here, and where the x and the 2 intercept, it's 3. So that's the value I'm going to put in here. And then I put minus because that minus sign belongs to the formula, okay? Now I'm going to go and find x1, and I find that x1 is -6. So I'm going to put -6 because this is the value of x1, okay? So this is x1, this is x1, this is x2, this is x2, and that minus sign there belongs to the formula, so I have to put it in there. Okay, and then I'm going to square that, and then I'm going to add y2, which is 1, minus y1 is -2, and then I can square it, okay? I really, really encourage you to write it that way. And then if you want to, like, okay, minus minus is a plus, I can now change that to a plus, and I can change that to a plus. But get in the habit of writing it out the way that is how you remember the formula. I promise you, okay? All right, so now I have the square root of 3 plus 6, or 3 minus -6, which is 9, and then I have to square it, plus 1 minus -2, or 1 plus 2 is 3, which are then square. So D equals the square root of 81 plus 9. Oh, look at that. It's the same thing. It's the square root of 90, which simplifies to 3 root 10. Okay, so we get the same solution. This next one says to use the Pythagorean theorem to find the exact length of AB and then express it as an exact value in simplest mixed radical form and then as a decimal to the nearest hundredth. I am actually going to leave this question for you to find a friend to work through. You can get up on the board, on the whiteboards, or do it on your desk or something, but I would like you to work through this yourself because this is not everybody's going to find this exactly straightforward. I will give you that the solution I got is that AB equals 2 times the square root of 29, which is approximately equal to 11.77, 10.77. I should make sure I get that right, 10.77. And then there's a thing that I do that I haven't actually done with this class much, but that is DIMS. It was up on my wall and it fell down. I got to put it back up. DIMS stands for does it make sense? So does 10.77 make sense as an answer to this question? So if this is 6 and this is 8 and that's 12, does 10.77 make sense for that? And when I look at that, I don't really think so because it looks like it's less than 8. But then I have to look at, is my drawing really to scale? I don't know. I don't think it really is. But honestly, I got that result and I went and redid all my calculations again to make sure because that number didn't really match the diagram I was given. And that's just an important thing to check, but you always like ask yourself if the diagram is actually to scale. Okay, all right, that is the end of this video. If you have trouble getting that answer, of course, come and see me and I'll walk you through it. Okay, bye.